Dear students, welcome again. The online lectures about the product design and the developments. In previous lecture, we have discussed about the design for the robustness and its applications and its parameters for design about the robustness. In this today's lecture, we have discussed about the safety and the application of safety for design the various products. So coming on the lectures, the objective of this lecture is apply and study the design safety approaches for manufacture the products. And the outcome of these lectures, after completion these lectures, students are able to apply safety approaches for design the products. So everyone is about the safety. What is meant by the safety? So here the system safety is a main role for every products, and where it is applicable and why the system safety is required for each and every products and each and every human as well as for the animals or as well as for the environment. The application of engineering and the management principles, criteria and techniques to optimize all aspects of the safety within the constraint of operational effectiveness, time and cost throughout all phases of the system life cycle is required. The system safety is a plan, discipline and systematic approaches to preventing or reducing the accident throughout the life cycle of the systems. Even system safety is a primary concern in the management of risk. The main three founding principle is required for designs for the safety. The first is safety should be designed for each and every process, each and every cycle, each and every product. Then inherent safety is also required for the all systems, and for its use, its applications, its user-friendly interaction, safety requirements is present or it's required for design that products or manufacture that product is very required. So basically these three founding principle is present for the safety. Then we are coming on the inherent safe design. So inherent belonging to the very natures of the persons or the things. It is recommended first step in safety engineering. Example, change the process to eliminate hazards rather than accepting the hazards and developing add-on features to control them. Unlike engineered features, inherent safety cannot be compromised. Minimize inherent dangers as far as possible. Example like the potential hazards are excluded rather than the just enclose or the manage. Another example, replace the dangerous substances or reactions by less dangerous ones. Use fireproof materials instead of the flammable ones for the pipeline systems or the any gas line systems. Inherent safe designs present in the four main methods. One is the minimize, second is the substitute, third is the moderate, and fourth is the simplify. So minimize is the reducing the amount of hazardous material present at any one time. The substitute is replacing one material with a less hazardous one. So example for the substitute, cleaning with water and detergents rather than the flammable solvent. Another inherent safe design is the moderate. It's reducing the strength of an effects. Example, having a cold liquid instead of the gas at the high pressures. Another example is also given, using material in a dilute rather than the concentrated forms. So it's indicate the modest. Then another is the simplify. It's designing out problems rather than adding or additional equipments or features to deal with them. So these are the four main methods present for inherently safe design: minimize, substitute, moderate, and the simplify. Even the inherent safe design, another two principles are sometimes cited for the manufacturing process or the design in the product systems. First is the error tolerance and second is the limit effects. The error tolerance example is given or where it is used when the equipments and the processes can be designed to be capable of withstanding possible faults or deviations from the designs. The example is present for the error tolerances, making the piping and joints capable of withstanding the maximum possible pressures if outlet are the closed. This is one example about the error tolerances. Then coming on the limit effects, it's designing and locating equipment so that the worst possible conditions gives less dangers. The example of the limits effects is the bungalows located away from the processes area. So these two are the some further principles for the inherent safe design: error tolerance and the limit effects. Then what is the difference between the passive and the active protection safety? The passive safeguards maintain the safety by their presence and fail into a safe state. Active safeguards requires hazards or conditions to be detected and corrected. The classifications about the trade-offs. The passive methods rely on physical principles. Then active methods depends on the less reliable detections and recovery mechanisms. The passive methods tends to be more restrictive in terms of the design freedoms, and active methods not always feasible to implement. This is the main difference between the passive and the active protection system. So active protections mechanisms. The active design solutions requires devices to monitor a process variable and the functions to mitigate hazards. The active solution generally involves a considerable maintenance and procedural components and are therefore typically less reliable than the inherently safer or passive solutions. To achieve the necessary reliability, redundancy is often used to eliminate conflict between the productions and safety requirements, such as having to shut down a unit to maintain a relief valve. So one example about these mechanisms. Then active solutions are sometimes referred to as the engineering controls. So the various example is given for the safety. So we are taking one or two examples about the safety. The first example is related with the industry safety. So in the industrial safety, we are used the different color codes and different marking for human safety, for machine safety, for operator safety. So typical 4 example is given related to the industrial safety. Safety footprint is present on the floor. Squared corners is also present on the floor. The stop floor sign is present on the floor, and rounded corners is also present on the floors. Why this symbolic representation is safety for the industry? We are coming on the details. The safety footprints. The footprint shaped floor graphics are a great way to show people which way they should be walking. So is a safety for that peoples. Then square corner. Whenever there is a corner along a warehouse, aisles or other area, make sure it is properly marked so people know to watch out for moving vehicle or other hazards. Then the use of stop floor sign. In some situations, it is easier for the people to see a stop sign placed on the floor than it is to see one on a post Combining the two can improve workplace and the visual communications. Then the rounded corners. Some facilities prefer rounded corners to make a smoother and cleaner look. Whether square or the rounded, making corners is very important for the floor or the industrial safety. Even the stop floor sign, in some situation it is easier for people to see a stop sign placed on the floor than it is to see one on the post. So these are the different symbolic representation is present in the industry for the safety, for human, for the machines, and for the another persons. Even the some color coding is also given for the industry, for different material, for environmental safety, for manufacturing safety, for selection of the proper material. So here typical example is given for the carbon steel, silver color is given, for the 304 SS yellow color is present, for the 316 LSS green color is there. This colors indicate which material is present in your racket, in your cupboards. So based on the color code, operators or the worker will be use or select the proper materials from that cupboards or from that stacking. Then in industry, the safety is present, and the safety will be fulfilled by using the wear the helmets on the heads. So typically 4 different color helmet is present in the industry. One is the black, one is the orange, white, and the blue. Based on the color, you can identify which person is wearing that helmets: worker, managers, supervisors, or any visiting person. Then another example is present in the RTO, road transportations offices, and they are designed some safety rules for human as well for the animals as well as for the environments, and we are follow these all rules and regulations, these all symbolic representations for our safety. Then another example is related with the products. So here is a electric product safety. How to use and how to achieve the electric product safety for direct online starter. So here the 3-phase supply is present, and I use the safety for that direct online starters. So the human interaction is connected with this DOL. Human interface is present. So avoid the shock, proper working of the systems, the safety is required. So the 3 different part is present in the starters: MCB, main circuit breaker, then so is a automatic system, and is a DOL system is present. So MCB is required for use the overload systems, overload trip. So is a safety about the overload. Then here the 4 LED is present, and this LED is indicate the supply is healthy, the supply is faulty, motor is on and motor is off, and means the displays indicate the safety about the motors and the supply. Then even the different color code is present for the wiring, for clockwise and anti-clockwise directions of the motors. Red, yellow, blue, black, or the green is indicate the RYB. Then for the starters, this 2 button is present, red in color and the green in color, and these are the push button for user friendly interactions about the switches. Red push button is indicate the motor is off when you press this button. The green push button is indicate the motor is on when you push the buttons. Then here some transparent glass is present, and inside the transparent glass there is one relay is present. By using the pressing this button, some magnetic field is indicated in that relay, and this relay will be lifted in upward directions. Then RYB contact is there, and through the input and output, the contact will be supply and motor will be start. So this transparent glass is indicate the relay is work properly or not. So these are the different safeties present about this DOL, direct online starters. So is a directly human interface is present, the life of motor is present, the color coding is present, the load is present, even the safety about this switch is present. Then in details about the DOL starter, then again this three different lug is present. This lug is indicate is the input for this DOL. Then another this three lug is present, RYB is indicate the output of this motor, either the input for the motors and output from the starters, and is the relay. So means this RYB, these are the inputs, then this RYB, these are the output. Even here is indicate the relay adjustment for the current rating. So means you can adjust the current rating of the motors based on its horsepower, based on its capacity. Then this two button is indicate, these are the push button, this indicate the on and off this relay. Then here the symbolic represent is present O and the minus sign. When the O is present in the transparent display, then you can say motor is off, and when the minus sign display is present in the glass, then the motor is on. Sorry, so here the correction is present. If the O display is present in the glass, then you can say motor is off, and if the minus side display is present in the glass, motor is on. So make the corrections about this two. So instead of the on, here it will be the off, so it should be the off, and when the minus sign is present in the glass indicator, and then motor should be the on. So this safety is also present in the air. So means safety is required for each and every products based on its use. It may be the for human, it may be the for the product, it may be used for the electricity. Then design for the safety is applicable for different type of the products, different type of the processes, and it is applicable for the design, manufacturing and developments for all type of the products, even for the hardware safety, is even for the software, is even for the different type of the machinery, engine safety, even it's for the rules and regulations, it's again useful for the human safety, food safety, animal safety and environmental safety. So safety is the main parameters, and you can say things for the product as well as for the human. So you can consider the safety while designing and manufacture that products. For this lectures, the references is given. Thanks for watching this lectures and video. Thank you.